So yeah, we'll start now. So basically, this week is more about uh, as Sir told, mm, like this, I can give you a simple diagram to remember by, like what is all about the content of this week. Let me just see. Yeah. So can you just confirm, Jagat, Rachagan, if I am audible? Mm, I think Jagat Rachagan is not uh, listening. Anyway, so we'll go ahead. So, so basically, the crux was uh, material requirement planning, which is MRP. It needs inputs from uh, master production schedule, and maybe I'll not put bracket everywhere because then it becomes quite clumsy. Uh, then there is inventory, and one more component to it is bill of material. And usually it is called as BOM, but so anyway, based on these three quantities or the three aspects, material requirement planning is done, and from material requirement from MRP, essentially uh, you get an output of order scheduling. So, and majorly you get an idea of order planning. So that it can be short term or long term, but essentially, if you remember this schematic, most likely you will be able to remember what we studied this week. And major part of the discussion was on uh, so basically, if I can just summarize, why do we do MRP? Essentially, as most of you can tell me, uh, the objective is to reduce the inventory, because if you have uh, you know unnecessary inventory, it carries inventory cost for storage, etc. Then you need to deliver, like based on MRP you do order planning and order scheduling, so that reduces your lead times, your current flow times, etc. And overall your efficiency of your planning and your production increases. And if you have proper MRP, if you are producing or delivering orders on quality, like on the desired quality aspect and on time or before time, then your customer service also improves, which in inherently or in which consequently leads to your growth of your business. So yeah, so basically MRP answers two questions. uh, you know, like uh, I mean, if you have MPS, inventory and BOM, all of this is put together in the MRP, and it gives you scheduling and planning, how it is to be done. So that is the main crux of this. Then there are small questions. We can take one question which is very common. I think it was in your assignment also, but this question is pretty common. So the question is uh, this thing regarding BOM. Let me just see the question. Actually, today I'm having slight cold, so please bear with me if I'm not able to talk in usual uh, voice intensity. So, yeah, I mean, the question is regarding the bill of material. So, BOM contains option 1. Just give me some time. Uh, I'm not able to find that question. I just want to misquote anything. Yeah, BOM contains sequence of operations to produce that product. Second, quantities of involved raw materials. Third, uh, mm, procedures involved in production of that goods or service, generally goods only. And fourth is mm, machines or equipments required for production. So I posed it as a question, but the answer is all of the above, because for making uh, any product, BOM is quite important. And if anybody of you have worked in the industry, you'll realize, particularly goods industry, not services. In goods industry, or in industry where you manufacture something, where there this BOM is quite uh, you know uh, quite commonly used terminology, and therefore uh, every information is given in a BOM for a particular product. For example, if you want to manufacture a soap, then in that BOM, BOM of that corresponding product code, you'll find what all, like how much quantity of uh, caustic is there, how much quantity of other raw materials are there, color, fragrance, how much is to be there, which, like on which machine for how long it should be there. So all those things are there in BOM. So that's why BOM is quite important. So uh, you can say uh, all of the above are correct. So this was regarding BOM. Uh, After that, inventory and this master production schedule we talked in the last class, so we'll not go there. Uh, so after that, there is one thing, one important this thing is called as routing. So as the name suggests, routing is nothing but path or the sequence followed by the corresponding product during its manufacturing cycle. So you should remember this definition of routing. This was discussed by professor, so I'm not going into details of it, but there are some questions which are frequently asked from this. And one of the important question is regarding this, I think, root sheet. So if I'm not wrong, one second, there is question on this. I saw it somewhere. Yeah, so the question is like for doing routing, there are multiple techniques, and one of them is this thing called as a root sheet. So that is quite frequently asked. I'll put the star here also. Yeah, so the important question that comes from this topic is regarding the root sheet. The root sheet contains information about, first option is order number, then sequence of operation, then processes, or to be more precise, process variables involved in the production, and fourth one is list of operations. So can anybody answer this one? Out of these four options, what do you think? What does root sheet contains? I mean, you can just take a guess also. There is no compulsion. Yeah, Ganesh, you had
I
unmuted
think
your.
yes.
Yeah,
So
go.
it's three.
No, the correct answers are 1, 2, and 4. You are
Oh,
telling
sorry.
what you are telling what is not there. Okay, these type of tricks are used in GATE exam. So anyway, yeah. So as this root sheet is used for routing, uh, it should have the identification of that particular product, which is order number. I mean, it can be order or product number, but if you are using routing for tracking your orders, then you can use order number as an identifier. Then sequence of operation, list of operation, and even name of different machines that are used for routing, that are involved in that routing route and all. These informations are given, but these process variables are not given in the routing sheet. They are part of BOM, as I told you earlier. The, that that information will not be in routing because it is not the job of uh, you know the person who is doing routing to know at what temperature or pressure the involved machines are to be operated. The primary job of person who is doing routing is to ensure that depending on what type of product and what type of plant layout you have, you should achieve maximum efficiency with minimum wastage. So that's how this routing is done. We'll see different things going ahead. There are different sequencing and all are also there. Majorly, the discussion for today's class will be on scheduling. We are just reaching there. I just don't want to miss anything before going there. So these routing etc. are okay, important thing, but for current discussion, there are some interesting numericals etc. So yeah, we'll go to the main part for this week's discussion, which is scheduling. So, as the name suggests, uh, scheduling gives you the information about. Uh, so, today's discussion will be primarily focused on this topic only. Scheduling tells you uh, when to, like, uh, where to produce, or where machine the product needs to go, and when it is supposed to go. So it answers two questions: when and where. So based on that, you can justify your definition of scheduling. But it is, scheduling, as the name suggests, it is basically the technique which increases your effectiveness of capital utilization. Capacity utilization. So there are different techniques that are used for scheduling. Uh, but before going that, uh, scheduling is important for, you know uh, important for job shop, or small volume productions. So this is important thing. Uh, so if you have a mass production, or you know a batch type of production, scheduling may be not that important, because in mass production, uh, your sequence of operations is fixed, sequence of machines are fixed. So in mass production, the important parameter that drives your production efficiency is, or the capacity utilization, is the line balancing. So we had talked about it in last, or I think previous class somewhere. Line balancing is basically, if you have, let's say, 4 or 5 components in series, which is typically called as production line, 4 or 5 machines. So first you identify what is the bottleneck, which machine is the slowest one, because that will limit your production capacity. And once you identify that machine, you try to figure out what can be done. How can we improve this thing? How can we improve the bottleneck constraint? Either you can go for better machine, or better resource for countering that bottleneck, or you can redesign your line. So there are different ways to tackle those things also. But basically, line balancing, the objective of line balancing in mass production type of layout is, or the product layout is, you want to have minimum idle time on any of the machine involved. So if you can achieve that, that will eventually result in your maximum capacity utilization. So this scheduling and different methods of scheduling are you know used for primarily for uh, small job shop or small volume productions, because there you have a number of machines, whereas your uh, production volume is low. So basically you are into maybe a specific, quite specific manufacturing type of, uh, you are manufacturing quite specific component. So not quite specific component. Basically, it's a very general component, but it needs machining from, let's say, 4 or 5 machines. So based on that, for those type of job shops, or maybe you can call it as small workshops or small volume production systems, there the scheduling is going to be important. Uh, so there is one important uh, tools, let's say, we'll just list down, because there is one important tool which is called as Gantt chart. So I think it is named after the person who invented this. It's quite old. So the most important thing that you should know is, Gantt chart only represents or shows time required for various operations. So uh, if you have attended the class, or maybe you have seen the Gantt chart on your job, or maybe on internet, or maybe somewhere during the exam preparations, you'll realize that in Gantt chart, usually on x-axis you have time, which can be in hours, in days, in months, depending on what product you are studying, and on y-axis you have number of this thing, what you call number of jobs. So like that. So basically, it is used uh, to monitor progress of your uh, production, uh, this production activities. So maybe I can just mm, actually drawing it. Okay, I can draw, but I'll just give you briefly simple drawing because this was covered in the class. Yeah, so as I told you, uh, in the rows you'll have different activities or different machines that are used in a sequence for producing that respective uh, product. So you'll have activity, let's say A, B, C, that I'm not listing down, and then you'll have let's say time. So basically, you'll have something like 1 second. Yeah, so you'll have sorry for the unequal distribution of columns, but uh, I'm drawing it by hand, so please bear with this. Uh, so you'll have time, let's say days, 1, 2, 3, 4, 5, 6 days, like that. So now, if you are planning to do this job, so what you'll do while scheduling, you'll uh, allocate start time and end time to particular activity, and these red brackets mark that one. So these the corresponding activity A is supposed to be over. It should be start from day one and it should be end by day two, and so that's how it goes. But what happens when you start, let's say your inventory did not arrive on time, so what will happen is uh, or your raw material got delayed because of some reason. So what will happen is instead of completing that task on day two, you overshoot your time by 1 day. Then the activity B, which was supposed to start on third day, it gets delayed, and then essentially the last activity, which was supposed to get over by sixth day, it will go on for next day. So that's how you monitor the progress using Gantt chart. So this blue line represents uh, actual progress, and red line represents this thing, planned progress or scheduled. You can call it scheduled also. So I hope it is clear to you. One important thing note you should note always is Gantt chart always has time on x-axis. It can be minute, days, whatever it is, but it always shows time. It does not tell you in that time what all things are supposed to be done. That is not the objective of this tool. There are other tools for doing those things, but Gantt chart only talks about time. So that is a takeaway. You can see one liner of this type in your assignments also, or in Gate also. So then mm, after Gantt chart, there are different scheduling techniques. Uh, I this thing they come under the category of this thing priority decision rules. We will take different examples of this because this is interesting and some maths is involved. Other than doing all theory, if we have some examples, that will be better, right? So this has, uh, let's say, first come first service or served, which is FCFS. There is something called as last come first served, but it's typically not used, so we'll skip that one. It was just a concept. Practically, I don't think it is used anywhere. Then there is earliest due date. So we'll take examples of this, but I'll just cover the theory first because then we can finish with the example. So there are different these things. Important ones only will study. Shortest possible time, which is called as SPT. Then least slack. So these are important four that we'll study. There are many others, but practically these four are used. And there is another type of tool, which is like mathematical programming. So uh, I don't know how many of you have reached this stage, but there are different techniques called as simplex method. Then there are PERT, CPM. So these are basically used for different projects. So not only in production, they are used in different projects also. So in projects there are a number of tasks, right? There is, if the project is big, so it will involve a large number of tasks and a large number of people will be working on different tasks. So in order to keep track of those projects and various activities that are going on in the project, you cannot rely on simple tools like these priority decision tools. These priority decision tools are applicable when you have small volumes or small projects. But when you go to a very complicated or very big or very lengthy or very this thing very highly like large number of people involving projects, there you cannot rely on this priority decision rules. You can use them, but their things are very complicated, so you need to take help of programming tools, and there are different methods. uh, Simplex is there, called CPM. So I think these are not in the course of this content course, but you should know that this is not the end of it. There are many other things. Then apart from this, in theory, mm, one second, let me just see. Yeah, then there is this concept called as workloading. uh, I'll not spend much time on it. I'll just advise you to go through it if you are interested. But the thing is, it is you should at least know this term. So there are two types: infinite versus finite. So as the name suggests, in infinite workloading case, you usually don't care about the maximum capacity of the machine. For example, if you have, let's say, a machine which can produce 100 units in 1 hour, which is a rated capacity. So what you do, you don't consider this number while giving the while scheduling the orders to be manufactured on this machine. So what will happen? One day you'll manufacture only 80 units. Next day you'll force the machine to produce 110 also. So if the machine can produce, it will produce. If not, it will break down. So that's the drawback of this infinite loading. But the advantage is, if the machine is able to take the increased load, you'll be able to achieve higher efficiency than planned. But usually that is allowed, that is not followed. Usually people or industry workers or employees don't want to harm the machine for short-term gains. So usually it is finite loading, and that too not up to the maximum limit. Usually, depending on industry to industry, 80-90% limit is only reached, because then the long-term capacity of machine reduces if you run it at 100% requirement all time. So that is one thing. Anyway, then there are type of schedulings: forward, backward. Uh, these are there. These keywords you should know, but they are not like uh, very important. Yeah, actually, I missed one important this thing also here in the priority decision rules. This is called as critical ratio. Uh, so we'll talk about this. Uh, so these things are there. So now let me just see. So critical ratio, since it's a ratio, uh, the formula is due date minus current date divided by, okay, processing time. We'll see some examples on this. So right now, just bear with the formula. Excuse me. So the problem is, if the constant is if CR is less than 1. So what does that mean? That means the numerator is smaller than the denominator. So basically you have less time to produce that unit relative to what it requires. So basically, if one unit requires 10 days to produce, processing time is 10 days, but you have only 5 days to deliver it. Due date is in 5 days. So that time the critical ratio will be half. So in that case, your job is behind the schedule. So the objective is to job is behind schedule. One second, actually, there is some B in my. Yeah, sorry for that. There was some uh, insect in my food. Anyway, so yeah, that is the importance of this critical ratio. So basically, if you find out that if for any particular activity your critical ratio is less than 1, then that means your job is behind schedule and you need to prioritize that one. So that is what it means. Then yeah, I think let me just see if any other this thing is uh, like question regarding theory is remaining. Other, if not, we'll go for this thing, numericals. So yeah, I think we have covered most of it. We'll define this slackness, tardiness while we solve the questions, because if you just give formulas without examples, it's not that it is not received in its full uh, capacity. So to avoid that, we'll start with the questions. So I'll take the Yeah, so should I take the example given in the class, or should I take example in the different one? Anyway, just give me some time. I'll see. See, the point here is I want to introduce these different terms which are flow time or completion time, or make span time, tardiness, etc. So yeah, so we'll start with the basic example. Here we'll define. It's not a question per se. It's a we'll define flow time, or this is called as completion time also. Anyway, we'll go with the term flow time. Then there is something called as slack, tardiness, and again critical ratio, etc. So we'll take one example. This example is, I think, I mean, you can change the time, etc. But just go with the simple example. There are, let's say, 5 jobs that you have to do in your uh, production capacity. So the processing time for each is 5, 11, 3, 7, 8. Okay, and due date is, let's say, 9, 15, 6, 4, 17. So these are some random units of time. Maybe you can consider it as a day. So what does, okay, Ganesh raised his hand. Ganesh, you wanted to ask something?
Yes, sir. So I think it's a silly question, but I just want to clarify with you that so in terms of industrial sector, that if we call something a job,
Hmm.
is it related to the product we are design? Sorry, we are product the product we are manufacturing, or the employee we have given the designation, sir?
Mm, in normal terms, you can say job means the designation of the person. But
Hmm.
for this discussion, job means uh, component or unit that is to be manufactured or produced.
Yes, sir. Thank you, sir. That's the question, sir. Sorry. Thank you.
No, it's fine. You can ask anyway. Uh, no need for sorry and all. If it is your doubt, it is a doubt. You can ask, or I mean, it's okay. No need to say sorry and etc. So let's yeah. So what we can do? So this is our job. We have to produce these 5 jobs in the given considering given constraints. So a job requires 5 days to work, 5 days of work to finish, whereas it is due in 9 days from today. So uh, then we can define this thing. Uh, let's say we start with this sequence only. We'll discuss different sequences going forward. So let's take first whatever is given to us. Let's take this example and stick it to it for the discussion of this lecture. So let's say you produce A, B, C, D, E in the same sequence and see what happens. So then this flow time. So if you start from, let's say, 0, and you need 5 days to produce the first job A, so flow time will be 5. Then you need 11 more days to produce B, so 5 plus 11, the flow time will be 16. Then you need 3 more days to produce job C, so that will be 19. You need 7 more days for D, so 19 plus 7 will be 26. And you need 8 days for E after 26, so that will be 34. So this is the flow time. Flow time is basically you know, you keep on just adding the processing time of each job. So like the definition says flow time is a time for a job to flow through the system. So basically, if you are talking about job A and job A to E, so what is the total time it required? So basically, for 34 days, the the 5 jobs will require total of 34 days of processing time. That's what it means. And then the usually what they do, there is this one thing which is called as makes span time. So basically, that is by definition, it is the total time that is required for all the jobs to pass through the system. So this last number that we encounter here, that is actually your uh, means this make span time. So there is no this thing. So that basically it means to complete this group of jobs, you need at least 34 days. That is your span time, make span time. And then one more question is asked typically is what is the average flow time? So basically, in now what you now need to do is you need to sum up this flow time column and divide it by number of jobs, which is 5 A B C D E. So if I sum it up, 1 second, there is one more insect in my room. Yeah, sorry for the disturbance, but I think there is some beehive or something nearby, because of which many insects are coming into my room. Anyway, moving on. So the average flow time per job will be calculated based on the summation of this flow times divided by number of jobs. So 5 plus 16 is 21, plus 19 plus 26 plus 34. So luckily it comes out to be 100. I mean, I've taken this number randomly, but it comes out to be 100. So that is your total flow time. So average flow time will be 100 by number of job is 5, so 20. Okay. Then there is this thing called as slack. So basically, slack is uh, you know uh, how much slack or how much time you can afford to delay this particular job. For example, uh, if I have to look at the example of job A, I need 5 days to produce it, but I have 9 days of delivery time. So I have 9 minus 5, which is 4 days of slack. In case of B, again same 4 days of slack. In case of C, I only have 3 days. 6 minus 3 is 3 days. In case of D, see this number I've taken randomly, right? So the problem is now uh, this D example, it is unrealistic, because if you need 7 days to produce something, you cannot ask for delivery in 4 days, right? So uh, this is infeasible, or this is unrealistic demand. So at least it should be greater than 7. So let's say 10. So or maybe okay 10. So we'll have 3 days here of slack, and here you have 9 days of slack. So uh, if you are a person who is responsible for producing these 5 jobs, you'll realize that uh, this job E, which is the 5th job, it has highest slack. So it has 9 days of slack. So you can deliver it. Let's say you don't start it on day one. Maybe if you start on the day 9, then also within next 8 days you can finish it and give the delivery on 17th day. So therefore the higher the slack, late delivery it can be done. So vice versa, if you have lower slack, you need to make sure that your delivery is faster, or you need to prioritize that job. Okay, so now here you can see there is a tie between job C and job D. Both have slack of 3. So which one will you prioritize? You can't say just because I like C, I'll do C. It won't work that way. So therefore, we have this thing which is called as critical ratio. So critical ratio is basically, as I told you earlier, the difference of due date minus current date divided by processing time. So let's say we are, uh, you know, on the first day itself. So the due date will take it as it is divided by processing time, right? So this will become 9 divided by 5. So that is 1.8. Similarly, you can do the calculation, right? So uh, this for job B, it is uh, due date is 15 divided by 11. So this is coming around 1.36. For job C, it is 2. For job D, it is 10 by 7, which is 1.43. And for job E, it is 17 by 8. So it is 2.13, let's say. So now you
Sir,
can see, okay, yeah, Ganesh, tell me.
sir, the formula is due date minus current date by processing time, right?
Yeah, so the calculations are done assuming we are on day 0. We are starting.
Okay, sir. Yes,
Yeah,
sir.
so that's why I'm just taking due date minus 0. So
Okay, sir. Thank you.
yeah, so now you can see uh, the see now here you are not getting equal numbers, right? You are getting distinct numbers. So you can use this critical ratio, and surprisingly in our example the CR values are all greater than 1. So no job is behind the schedule because we have not started it, right? I mean, we are on day 0. So this CR has to be 1 greater than 1 for each job. So now the question is, how will you prioritize? So there are, as I told you, there are, let's say, 5 6 ways to do this. So we'll take one example. We'll leave this one example. This was I took it randomly. But yeah, 1 second. You have average flow time, which is calculated by total flow time divided by number of jobs. Then there is something called as average number of jobs. So this question is very frequently asked in GATE exam. Uh, so I'll just tell you. The formula is total flow time divided by make span time. So total flow time is 100 divided by make span was 34. So it will be around 3 point, let's say 3. So basically, on an average, there were 3.3 jobs in the system. So you should remember this one because it is important for GATE exam. Other than that, this tardiness and all, we'll talk in the examples because there is not enough space here. If I put it here, it will become quite uh, cluttered. So let's go for an example and then we can discuss this thing. So I'll take one example. Uh, Let me take one example which was asked in the GATE exam, I think. 1 second. Mm, yeah, so the thing is, let's take this example. So you have list of jobs. Again, there are 6 jobs here: A, B, C, D, E, F. Okay, and you have uh, processing time of 4, 16, 8, 20, 10, 18, and then you have due date for each job as 14, 32, 8, 34, 30, 30. So now the first question is uh, based on shortest possible time, which was this one of the C, shortest possible time, SPT. First, you need to decide sequence of jobs based on SPT. So uh, this is examiner's choice, or maybe your choice if you are actually producing it. But if you are preparing for gate and all, this will be given in the question. So now, as the name suggests, shortest possible time is in this method. What you do, you decide the sequence based on shortest possible processing time. So now, if you look at the processing time column, you'll realize that A job takes the least time, then C, then E, then B, then F, and then B. So you have this sequence because of this keyword. If it is different keyword, then the sequence will change. But let's stick for this question with this keyword. And now, typically, the things that are asked are uh, average flow time. 1 second. Average tardiness. And average number of jobs. So these are typical things that are expected in this type of questions. So now we'll go. So now the thing is, if you have, if you want to solve this question, one very important thing is when you reshuffle this order, which is given in this question A, B, C, D, E, F, but now the sequence is A, C, B, F, D. So you'll reshuffle these rows. So when you reshuffle these rows, shuffle. Okay, I'll just explain rather than telling you what am I doing. Uh, so what I'm trying to say is one mistake that people generally do is they'll just shuffle processing time. They'll keep the due date same. So that should not happen. Otherwise, it is, I don't know why this is happening. Where is it pasted then? What is wrong with this guy? Anyway, we'll write it again then. 1 second. So the solution goes as follows. Again, so now you have different sequence, right? Earlier it was alphabetical. Now, based on the shortest possible time, you need to change it to A, C, E, B, F, D. So the thing that I was suggesting earlier is uh, now you'll have to write the processing time and due date. So when you let's say A will remain like this only, but if you write C, write 8 and 8. Some people, what they do, they'll just write C and processing time 8, but they keep due date as 32. So which is for B. So don't do that, because that's wrong, because these due dates and processing times are for a particular job. They can't be interchanged. So if you are shuffling the sequence of jobs, shuffle the respective times also, otherwise it is wrong. So then AC, this thing, 1 second, what was it? AC VFD. So ACE 1030, B 1632, F 1830, and D 2034. So this is this thing. Then we'll calculate flow time. So yeah, you are starting with A, so you'll need 4 days to finish it. Then for C, the total waiting time in the system or flow time or completion time is 4 plus 8, because 4 days are gone for A, then 8 days for C, so total will be 12. Till E it will be 22. Here it will become 38. Here it will become 56, and here it will become 76. Then yeah, so now there is this thing called as tardiness. So as the name suggests, I hope yeah, Ganesh, ask, go ahead, ask, what is your question?
Sir, so why are we taking 0 for every time when we calculating the flow time for the first job? Like we're directly getting the value of 4, right?
Mhm.
By adding 0 to it.
Yeah, so we are taking the starting time as 0 because uh, see, the thing is, I understand your confusion. Maybe you are thinking like, let's say I started and I have reached 10 days, and then if I'm doing these calculations, what will happen? But mm, you can do the same procedure, right? See, uh, this this calculation we are doing, assuming we are at day 0. We are just going to start and we don't know which job to take first, right? So that's why whenever I say this, whenever I calculate this critical ratio, etc., I am not deducting anything from due date. I am assuming I am at day 0. But if you
Okay,
are,
sir.
so that simplifies our job. Nothing wrong in it. For example, if you tomorrow, let's say for this question only, you completed, let's say 10 days, then what will happen? Most likely your A job will be finished because it requires only 4 days and you are doing it first. Then on 10th day, most likely you will be doing some job, this C job, because it requires 12 days straight from start. So then if on 10th day, if you do the planning, then you have to consider 2 days for C and leave that. Then you'll have only 4 jobs, E, B, F, D. And then you'll see that should I use the shortest processing time criteria or earliest due date delivery, etc. And then you can modify, but the procedure remains same. So the point of doing these exercises is to understand the procedure. Uh, you
Yes,
can
sir.
uh, you can tweak it as you want as you go along the time.
So if I start this procedure, sorry, if I calculate this procedure
Mm.
about after 5 days,
Mm.
after starting my manufacturing after 5 days,
Mm.
so I should take that fifth day from the fifth day by starting C, right?
Yeah, but you would have started C already, right? Because on fourth day your A will be finished, and for 1 day you will be doing C, right?
Yes, sir.
So it's better to start on, let's say, at the end of fourth day. Then your A job is gone, so you only have 5 jobs, and then you can do the same calculation. If you want to use this shortest possible time or shortest processing time criteria, use that. Otherwise, let's say it happened that some like delivery you have to do it urgently because the delivery or the person who was asking for delivery has some emergency. Then what you will do, you will not look at the processing time. You will look at the due date, and then you will reshuffle again, right?
Yes, sir.
So that's how it goes. For here, what we are considering, what the underlying assumption is we are at day 0 and we are using SPT, shortest processing time. So
Okay,
what
sir. Yes.
yeah, tell me.
Sir, the thing is that so it's better to go for the fourth day rather than in the middle of days, right?
Yeah, because you'll be already in some job, right? How will you reshuffle that job? You have to finish
Okay,
that
sir.
job, right?
Yes.
Yeah.
So, better to go for the fifth day, sorry, fourth day, not with the fifth day, but also to the 12th day.
Yes, yes. This flow time, in the flow time column, whatever numbers you are seeing, when you reach that day, you can do the reshuffling for next remaining jobs.
Yes, sir. Thank you so much.
Yeah. So now the tardiness is this thing. Uh, the it goes like uh, uh, like if your due date is away from your completion date or completion time, then there is no tardiness, right? There is no delay. You are finishing before the time. But when your completion time is higher or more than the due date, then only tardiness comes. So tardiness is basically a measurement of how late your deliveries are going to be. For example, see for job A, you need 4 days, but you have 10 days or you have 14 days of this thing 14 days of due date. So you don't have any tardiness, right? You have zero because there is no delay. But in case of C, your completion time or flow time is 12, but your due date is 8. So you are late by 4 days, right? So your tardiness becomes 4. And for E, you can finish it in 22 days, but you need to give it in 30 days. So there is no tardiness. You have 8 days of extra. So that is what slack is. We'll discuss that later. Then here for D, you need 38 days from start, but you have to deliver this in 32 days. So there is a delay of 6 days. Similarly, for F, you have to deliver it in 30 days, but you need 56 days. So there is a big delay of 26 days here. Similarly, for this guy, there is a delay of 42 days for D. So now you can see, right? For first 3 jobs, your system is okay, or even for first 4 jobs. But for last 2 jobs, your delay is quite high, 26 days and 42 days. So that is a problem as far as I can see. But let's solve this problem, then you'll understand what is it. And one more thing, this regarding this Slack. So if you are at, day zero, uh, I'll just put here Slack column. And assuming we are at day zero, we are not somewhere in between. We are at day zero so that our calculations are easier. So, as the formula says, the slack is due date minus your processing time, and assuming you are at day zero. So, due date is 14, your processing time is 4, so your slack will be 10. Here, 8, 8, so there is no slack. So, once you start this product, you have to finish it in 8 days. You don't have extra luxury or anything. Here, you have 20 days of luxury. Here, you have 16 days of slack. Here, 12. Here, 14 days. So I hope now you can understand how to calculate tardiness, slack, etc., flow time, etc. And this 1776 will be your uh, 1 second. Yeah, 76 will be your make span time. So yeah, so now it is asked us that what is average flow time. So for average flow time, as we did earlier, we need to sum up the flow time column and divide it by number of jobs, which is 6, and the summation will be, let me use the calculator, 4 plus 12 16 plus 22 plus 38 plus 56 plus 76. So this is 208 divided by 6. This gives you 34.67. I am not putting unit here, okay? So you need to understand, if the processing time and due date are in days, the average flow time will be in days. So that I am leaving up to you. So let me just see the answer, whether we are doing it right or not. Yeah, so the answer is 34.67. Now this thing is also asked average tardiness. So see, wherever average is asked, what you need to do is you need to sum up the column divided by the jobs. So tardiness is sum of 32 plus, sorry, 36 plus 42. I think it is 78 by 6. Uh, I think it is correct. Yeah, so 78 divided by 6, 13. So average tardiness is 13 units of time. Then the last was average number of jobs in the system. So as I told you, it is total flow time divided by this thing, make span time, which is 76 here. So if you do that, you'll get 208 divided by 76, which is 2.74. So on an average, there are 2.74 jobs in the system. So yeah, so now you may ask me, okay, we are doing these calculations, but what is the point of all this, right? Because as I told you, these last two jobs, they are having quite high number of days and high tardiness. So my answer to you would be, see, this is according to one set of this thing, this SPT, right? In reality, what you do usually, if you have this problem, you construct one table. What the table should look like, I'll tell you. So okay. Hmm. So there will be comparison between 2, 3 these things. So what you'll do, yeah. So first of all, you'll do the calculation using shortest possible processing time. Then what you'll do, you'll repeat the calculations using earliest delivery date. Then what will you do? You'll repeat the calculations using this thing. What is remaining? FCFS, first come first served. Then you'll do this maybe CR based. So that is how you do the calculation. And what you observe, let's say you use two parameters for comparison. So let's say you use average flow time and average tardiness. So in SPT, we got average flow time of 34.67 and average tardiness of 13, right? So uh, that is one thing. And let's do some calculation. Let's say if we do it using FCFS, so so in that case, since the table is ready here only, I'll quickly do the calculation. Yeah. So you'll finish the first job in 4 days, and we'll make the column of tardiness also. Let's go with it, and we'll calculate this thing CR also, so that we can use it later. So since we have, let's say, some more time, we'll do these calculations. So yeah, flow time is 4, then it will become 20, 28, 48, 58, 76. So the point is, make span time will remain same for any criteria that you use, because uh, you are just reshuffling it, right? Whatever processing time is there, the total will be same only. So 76 is again this thing. Now let's look at the tardiness. Here for A there is no tardiness because you have quite this thing, ample amount of time. For B also there is no tardiness. C also no tardiness. D also no tardiness. See, there is no tardiness at all, because oh, I'm sorry. Uh, I compared the wrong columns here. So so now you should compare due date and flow time, not the processing time. Sorry. So uh, you need 20 days and you're delivering in 32. So there no tardiness. Here you need 28 days, but your delivery is supposed to happen in 8 days. So you have tardiness of 20. Here you have tardiness of 14. Here you have tardiness of 28. Here you have tardiness of 46. And assuming we are at day 0, we'll calculate the critical ratio. Is it critical only, right? Yeah, critical ratio. So due date minus 0, which will be 14, divided by processing time. So 14 by 4, 7 by 2, 3.5. This will be 2. This will be 1. This will be 1.7, 3. 15 by 15 by 9, 5 by 3, which will be 1.67. So we have calculated all this, and this is assuming F, F, C, Fs, first come, first serve. Okay. So now if I do I'll just calculate this thing. Okay. Average flow time and average tardiness. So this will be 24 plus 28 plus 48 plus 58 plus 76 divided by 6. So it comes out to be 39, which will be like 234 by 6, 39. And this will be 34 plus 28 plus 46 divided by 6, 18. So now what you'll do, you'll go back to our table, and for FCFS, you have 39 days of flow time and tardiness of 18. Okay, so now we'll do for, let's say, CR also we'll do. Now, as you know, when you look at the critical ratio, the important thing to look at is the priority should be given to the job which has lowest CR. So in our case, the lowest CR is C, then D. Oh, sorry, C, F, D, like that, right? Okay, I'll write down. Uh, Maybe I should do. Okay, anyway, I'll insert some space here, because this table should come at the end, right? After all comparisons. So now, let's say we are going with the CR criteria. So here the sequence will be lowest CR is 1, which is C, then F, D, C, F, D, and then C, F, D, D, E, A. D, E, A. Okay. So now again we have to repeat the same thing. One second. Okay. So job C, F, D, B, E, A. Then processing time, then due date, load time. When we are using CR, so we'll just write it 1.67, 1.7, 2, 3, 3.5. Am I right? Yes. So C had 88, F had 1830, D 2034, B 1632, E 1030, and A 414. So now flow time 8, 18 plus 8 is 26, 46, 62, 72, 76. Again, see, this max span is 76. So that is actually one sort of indication where you can, you're sure that you're not doing any mistake or something. So then we'll calculate average flow time, which will be let me do the calculations. So 8 plus 26 plus 46 plus 62 plus 72 plus 76 divided by 6. That will be 48.33. Oh, and we forgot about the tardiness. So, okay, due date 8, flow time 8, so there is no tardiness. Here the tardiness is 0 because we have 4 extra days. Here we have overshoot by 12. Here we have overshoot by 30, 42, 62. Bapre. So this, by the looks of it only, this looks bad. Anyway, we'll do the calculation. It will be 62 plus 42 plus 42 divided by 6. So 24.33. So we'll just put up the numbers. 48.33, 24.33. And shall we do it for EDD? Okay, we'll do it in 5 minutes. So can I just copy this? Anyway, EDD criteria, which is earliest due date. So just look at the due date column in the question. So what is the earliest due date? It is C. You have to deliver it in 8 days. Then, oh, sorry. A is delivered to be delivered in 4 days. Sorry, I looked at the wrong one. C, then A, 14 days delivery. Then we have E and F, which is tie. So we'll just go with the so now we have tie in E and F. So ideally what you should do is you should do the calculation assuming E and F first and then with F and E. Numbers should not change much, but you should do it both ways and you should see. Here we'll do it one way because we have a time constraint. Then we'll do B, then D. So again, job, PT, due date, flow time. We don't need CR here. We'll just go for tardiness. So then this is C, A, E, F, B, D. For C, PT is 888, A 414, 1030, 1830, BD 1652, 2034. So again, same thing. We'll calculate the flow time 8, 12, 22, 40, 56, 76. So we are correct. 76 we are getting. So average flow time is 20 plus 22 plus 40 plus 56 plus 76 divided by 6, 35.67. And the tardiness is here 0, here 0, here also 0 because we are doing it in 22 days only. Here it is 10, here it is 24, and here it is 42. Yeah, so it will be 42 plus 34 divided by 6, so 12.67. So yeah, we have filled our table finally. So the point I was trying to make earlier was this only. So now you have see, you have used two categories of flow time and tardiness, two parameters to decide which criteria is better for you, whether SPT, EDD, ECR, FCFS. Okay. So now let's compare flow time, average flow time. You can see the highest flow time is the in this CR, and okay, I'll just use different color. So this CR is having highest flow time, and this SPT is having the lowest flow time. So okay, I think it is not better this way. What I'll do, I'll just write it down. So based on average flow time, the lowest is with the SPT, then EDD, then first come first served, and then CR. And on average tardiness, lowest is EDD, then comes SPT, then FCFS, then CR. So the point I'm trying to make here is, yeah, Ganesh, you wanted to ask something?
Yes, sir.
Yeah.
So we are calculating all these tables because to have a perfect sequence so that we can build a perfect production line, right?
Okay. Not production line,
So
but sequencing schedule.
yes, sir. Scheduling a perfect sequence.
Yeah.
So why can't we go for the mass production in this way? Because in mass production we go for the line balancing, right?
Yeah.
So as of the line balancing define that is it a sequence to get a product in a vast product sorry jobs.
Yeah. So there, if you remember, I think last or before that, we discussed one thing called as cycle efficiency, cycle time. So there what happens, you don't have different jobs, you only have one job, and you have 5-6 machines to do that job. So there you optimize the cycle time for each machine, or bottleneck, etc. Here it is different, right? Here you have different jobs and different times. Here I have not mentioned any machines because that is not required, but this is different and that is different. There the objective is to balance uh, the objective is to have maximum production rate, because you need to keep the machines idle for minimum time, right?
Yes, sir.
Here we don't care about machines can be running or not. In this, let's say for job C, processing time requires 8 days, right? But out of that 8 days, for how much time these all of the machinings are idle and all, that is not possible to calculate, right? Because there is no sequence here. This job C, can we go to machine 1, machine 2, 4, 5, 8, 9, like that. But in total, it will require 8 days.
Okay, sir. Okay, sir. So while in the batch production, we got to be mixed with the process and product, right, sir? Is it right?
Don't mix batch with there because you'll get confused. Keep product and process separate, and maybe you can consider job, batch, and mass. These three together.
Okay. Yes, sir.
Okay. So yeah.
Thank you, sir.
So we'll conclude today. So the thing is, see here you can understand this critical ratio criteria is worst because it is giving you your system is operating for 48 days and the tardiness is also for 24 days on an average. So you should not go for CR. Then there is a trade-off because SPT is giving minimum flow time, but it has higher tardiness, and vice versa for EDD. So now it is your call, depending on your priority, whether you want your system to run for minimum time or you want your tardiness to be minimum. If I am there, I will focus on tardiness because tardiness, as I told you earlier, it is the indicator of delay in your deliveries. So that affects your customer relationships. So I will go for EDD criteria here. But for some businesses, maybe EDD is not suitable. They can go for SPT. But in any case, they should not go for this CR. So that is the whole point of this exercise. I hope it is clear to you, Ganesh.
Yes, sir. It's clear. And so, what is this CR tends to do for in the business terms, sir?
So basically, CR gives you a measure of urgency. So what happens if for any job, if your CR is less than 1, then you are already delaying. That job is going to be delayed in any case. If CR is coming less than 1, that means that job it will be delayed. So now your objective becomes to minimize that delay. So then what you do, you prioritize that whichever has lowest CR. So basically it is an indicator of urgency, which job is to be prioritized considering the delay in the delivery.
So it should be greater than one or less than one, sir?
It should be as high as possible. It should not be less than 1. When it is less than 1, that means you are already going to get delayed on that order. You are
Oh,
not going to give it in time.
okay, sir. Yes, sir.
Okay.
Clear, sir. Thank you.
Okay. Then shall we stop for today?
Yes, sir.
Okay. Okay then. Good night, Ganesh. See you next time.
Thank you so much, sir. Good night.